Yeah. This started in the 1980s. I worked in the Philippines for Intel manufacturing. Intel makes the CPUs, right, in our computers. It is the Philippine manufacturing plant. They do assembly and test. And that was 1981. And that was the year the IBM PC was introduced to the world. And being a company, an American company, even if I was in the Philippines, I had access to the first IBM PC. And I used it for my work in Intel. And I became very fascinated in how computers can be used to do analysis of data, right, to improve the manufacturing yield. How much to control the defects, etc. So I began to be very interested in computers to analyze performance of machines. But then it just did data analysis, but it doesn't control the machine directly. So then I began to decide to be interested in maybe besides giving analysis of data, maybe the same computer can control the machine directly. So the human no need to adjust the machine parameters and do the experiments again, etc. And that is really what robotics is all about. There is intelligence that of data analysis, and then that intelligence is converted into actions. And the actions is really how to change the performance of the machine. So because of that, I left Intel and decided to go to the United States to pursue my studies, to study more about this. Then I spent 2 years in Hawaii, where I built a computer, a machine to harvest sugarcane. Because Hawaii sugarcane industry is a major industry that uses an Apple IIe computer. I don't know, that was so long ago. IBM PC was IBM, and Apple had their Apple IIe computer. Then after that, I went to Rochester to do a PhD, and somewhere in between, I spent a summer working in MIT in Cambridge, Massachusetts, where I began to be to have experience in robotics in manufacturing. Well, Hawaii is robotics in agriculture, right? Then I completed my PhD in electrical engineering in University of Rochester in US. Then in 1989, I came to Singapore to start robotics in Singapore, right? So I've been working in Singapore ever since. My background is mechanical engineering, bachelor. My PhD is in electrical engineering, which is nice because robotics is really intersection of both mechanical engineering, electrical engineering, and computer science. So I've been working ever since. And in the last maybe 20 or 25 years, and there become a renewed interest in neural networks, which is really modern AI. To be specific, is machine learning. So I began to work on machine learning to improve the intelligence of robots, because it's very hard for robots to give it the necessary understanding so the robot can understand the environment and do action. That's right. So artificial intelligence, specifically machine learning, specifically neural networks, provides a very attractive solution. So that's how I became more interested in robotics. There are two main areas in robotics. In terms, one is mobility, or the robot must have a base that is able to move around, to travel, to locomote, right? And this gave birth to this interest in autonomous vehicles. Autonomous vehicles can be cars in public roads, can also be vehicles in warehouses, doing warehousing, right? Or vehicles doing delivery of food, delivery of packages. So that's mobility, number one. And number two is robotics in terms of manipulation. In other words, an arm that does pick up objects, clean tables, do some tasks, and the task is manipulation. So my current research involves these two areas: mobility, how to make the robot be able to move its base intelligently, whether in public roads, public areas, or warehouses. And on top of this mobile base, there's an arm that does manipulation. Today, if you look at delivery robots, they just deliver food in the restaurants or packages, but there's no arm, right? But it would be nice if the robot or the mobile robot also has an arm, so it can actually pick up the package and hand deliver it to you, literally. So I'm very interested in that. And that's my research is bought, and the applications are so wide. It can be in land or also underwater. I also do a lot of robotics underwater, and to a lesser extent also drones, flying robots, right? But most of the work is on land. Next is on underwater or boats and submarines. Then the third will be on the air, right? And to achieve these capabilities, I work both in hardware, in building robot hardware, and also in the intelligence, where artificial intelligence is very important. The robotics has been very successful in factories, in manufacturing, and factories are characterized by structured environment, meaning there's the knowledge about the environment is exactly known. There's no uncertainty, and robots are very successful there. They've been working, right? Another characteristic in this factory, there's no human involvement. The human is outside the robot workspace because of safety, right? And this is very good. But the bigger impact or the bigger application is moving out of this factory to everyday life. Now, when you move everyday life, the structured becomes unstructured. Things are not where they're supposed to be. It's very chaotic, right? So we need better intelligence in how to deal with this, right? To understand what's going on to the world. In the factory environment, you don't need to understand because it's already known. What's happening is known beforehand. But outside the factory to everyday life, it's unknown, right? So, secondly, outside the factory, there are human beings. So the robot will be working closely with human beings. So there's human-robot interaction. So the robot must understand how it can work with humans and be able to predict what makes a human happy, what makes a human sad, and how best to help the human, right? So the robot must have this understanding. So these really are the new challenges that we need to solve. How to make robots be more intelligent, to understand the environment, number one. Two, second is to plan its action based on the understanding of the environment. And number three, how to continuously learn from it, right? So it gets better and better. And as it's doing it, as it's getting better, it's interacting with human, so the human can use the robot better because robot is more intelligent. At the same time, the robot can improve its intelligence by learning from humans. It's almost like the robot becomes your assistant. The first time you have an assistant helping in your work, you may not be able to work together well. But after 1 week, after 1 month, after 1 year, you get to know each other better and you work better together. So there's a lot of learning how to for robot and human to work together. So that is really the research challenges today. And to do that, it's not only intelligence of the robot body must be changed, right? We need new designs of robots because those robots that we have today are meant for factories. You don't want these robots to be inside your home, right? Yeah, because you want robots that are soft. That's why there's a new branch of robotics called soft robotics. At the same time, you want them to be cute and lovable, right? So you're not afraid of them. Yeah. academia really is very important because it does basic research. It's the lowest level of research. In other words, it's something we call technology readiness level. It's technology readiness level from 1 to 3, right? There is a scale from 1 to 9. 9 means already out there in the field being used. 1 is still in the very exploratory, right? So it's very important to build the fundamental science and technology to achieve better capabilities. So that's the role of academia. But then the academia, that is not enough, right? At the same time, academia must know what are the problems in the world today, right? And how robots can help,
Yes.
right? So even if it's very far away, there is a path towards this goal. It can be 10 years away or 20 years away even, but whatever fundamental science and technology we are developing as academia must have a link to this future goal, right? So there must, although it will take longer. So it's very important to know what are the problems so that we can link it, right? So we can do the building blocks to solve. It's like building a big complicated puzzle, right? It's very hard to solve everything immediately, but you solve one part of it, then next year another part of it, then eventually the puzzle will be formed and you get the big picture. And after you solve the puzzle, you make the puzzle more complicated, you make the puzzle bigger, and you have to solve more pieces, put more new pieces to complete the bigger picture. And as we're doing it, right, life will continuously improve, right? So I advise people who are young or are new fresh PhD students, even the current students, to really look at the world, see what the problems are today, whether in your home, in factories, in your work, in the buses, transportation, right? And see at the same time, study what robotics capabilities we can do today, right? And see what can be done, what cannot be done, and try to see if it can be done. Why is it not applied to solve this problem? Maybe it's not applied because we still have some missing pieces. Then they can start to know what are the missing pieces and work on it. So in summary, there are two important things that I think I advise my students always to know. First is, what is the state of the art in robotic capability? What can robots do today? What it cannot do today, right? What are the problems of current robots, right? Number two is, what are the use cases? What are the problem statements, right? And why don't we have robots doing it, right? Then we can link these two together. What robots cannot do, what are the use cases, and from these two, we will know what is the missing items. And that will be their PhD project, their master's project, building pieces together. One example, for example, is cleaning toilets. It's so hard to clean toilets. Nobody wants to do that. Can we build a robot to clean toilets for us? Right? That will be very interesting too. That's just one example. I think journals are very important to spread the latest advances in science and applications, so that when people try to solve problems or create new solutions, they won't reinvent the wheel, because journals will already show and they can build on top of what is known. Now, since journals present latest ideas, latest development, it's important for them to be timely, right? To be fast. And that is the main difficulty in any journal. How to find good reviewers, right? And the reviewers must agree, because everybody is very busy, as you know, right? And how to speed up this process. And we can speed up this process is to provide tools, IT tools, for the editors who find reviewers, and make it easy for reviewers to enter their comments, right? And to make it as easy as possible for them to accept the review request, right? For example, we have a database of potential reviewers who will agree, maybe giving some benefits to the reviewers if you give a timely review, give some rewards, and things like this, and then allow the system to be very easy to use, so reviewer can just click a button to accept. No need to fill in too many fields, right? And then he can concentrate. He or she can concentrate on the technical details of the review, right? So it's really creating a very nice information technology system to facilitate finding reviewers, to facilitate how reviewers assign, how as editors assign reviewers, how reviewers submit their reviews, and how the editors who look at the reviews can decide on the status, right? Without having to look for emails. What did this guy say? What did this other guy say? It will be a very good IT platform. And another suggestion is we have to really look at trends in technology, recent developments, and plan on encouraging submissions in these new areas that are emerging. For example, special issues on some thematic areas would be very good too. For example, there's a lot of interest today in machine learning, in large foundational models, and how it's applied to robotics. That can be a special issue, or even inviting some very important distinguished researchers to write articles. That would be good too. Yeah. So I hope the journal can be very timely in distributing latest developments, and in that way it will be very well cited, right? So that's my expectations. And I think the word intelligence and robotics is very good together, because robotics without the intelligence is useless, and many of the challenges why we cannot make robots operate in everyday life compared to factories is because of the intelligence. That's primarily. But there's also the secondary reason is we need to build better robots. The body of the robot must be softer, not those industrial, for safety, and so that humans can be happy working with robots. Yeah.